All right. Um, I grew up in my village where we have a well in our compound. Although I saw the well being dug, when the well was dug, people normally come to even fetch from our compound. I think up till now. So discovered that by the time we want to draw out water from the well, all we do is to use our hand and draw up the bucket up by ourselves. That is up like this, directly like this. Until I was able to, travel and see a lot of things. Discover that there are some wells that you don't have to start drawing up yourself. What you do is you just have to make a kind of a bar whereby as you are turning a handle this way, you are turning the handle this way, the water or whatever that is under a well can be coming up. That is exactly what we call a well and an angle system. Discover that the particular area where the rope is being tied to draw up the water is always smaller than the length of the bar, which when you turn will give you this circle, this big circle. So it's more like something like this. Yes. By the time you turn this way now, this one turn this way, this one turn this way. So what happens is that as you turn this way, that is exactly how the effort is moving. So the effort is moving around the circumference of this wheel, while the load is has to rotate, has to turn around the circumference of this small wheel, which we call the axle. So this bigger one is the wheel, while the smaller one is called the axle. That is wheel and axle. The question now is, how is it even a machine? Yes, it's a machine. Even without being told, it be easier for you to just stay one place while you run the the wheel from the handle. You can even be making call, feel relaxed. So it requires less effort to draw the water by simple turning the wheel this way than you drawing with your full strength like this. It's easier. Now, how do we now find the velocity ratio of this system? It's quite simple. Let's dive in. The velocity ratio of any machine is given as so let's put this guy here. G. D is equal to 2 small r. Velocity ratio of any machine is always given by distance moved by the effort divided by distance moved by the load. The question now is, what distance is being covered by the effort? Now remember that the effort is moving around this circular periphery, something like this. Look at this. Look at this part. If I wrap, sorry please, if I wrap something like this now, so for one ton, the effort has moved round from here to here. Distance covered by effort is given as the perimeter or circumference of this circle that makes up the face of this cup. So let's show that as something like this. So the whole of this is the circumference of the wheel. Yes. Likewise, for the axle will now be the smaller one inside. Yes. This distance moved by the effort is the outside one. That of the axle or by the load is the inside one. Now, how do we find the circumference of the circle? For the wheel, the diameter is capital D or 2 times capital R, which is the radius. While for the axle, the diameter is small d, which is equal to 2 times small r. So circumference of a circle is given by circumference C, So distance moved by the axle, by the effort, which is the diameter of the wheel, is given by xe is given as pi d, or equals to pi times 2 capital R, which you can write as 2 pi capital R. All right. Now distance moved by the load, which is just one round, as this one moves one round, this also moves one round. So one round of movement of the effort leads to also one round of this. So this will now give us, don't forget, both are concentric circles. So there's no relative motion. They are just the same, they move together. So XL is given as equal to pi times small letter d, which is given as pi times 2 times small letter r, which you can write as 2 as 2 pi small r. So that the velocity ratio now is now given by distance moved by the effort 2 pi capital R over what? 2 pi small letter r. This can cancel out. So it's given as capital R over small r equal to capital D over small d. Please, for JAMB students, do not, most of the times, the diameters or radius of these machines, they are always given sometimes in cm, sometimes in millimeters. Don't waste your time trying to go and convert to meters. It is not needed. If you have capital R of 8 millimeter and a small r of 2 millimeter, whether you convert this or not to meter, you see have the same, you see have 4. So as a JAMB bite, once you see the radii of the two wheel and axle of the same unit, don't convert, solve it like that, you still get your answer, please. Don't waste your time. So we'll still post more videos on machines and other things that will assist these JAMB students. Please, I have a personal Telegram channel where I solve all these things again. I have over 200 questions in JAMB, and I will be giving you tips on how to solve them. Each question within 30 seconds to get your answer. 30 seconds to get your answer. And again, I also have a live Google Meet classes for WAEC and JAMB students. Click the link or the number on the screen where you are seeing this video now. Make sure you subscribe to the Telegram channel and do well to also enroll in the live class whereby we'll be treating these questions topic by topic. I will be giving you trends on what you should expect for any topic I take. So do well to like, comment, and follow this page immediately. Thank you.